distribution, 4.1. This is to binomial. So you don't have to type all these things in, but I find it's helpful. We should have N, P, and Q listed somewhere up there to set up here. So you can even put in X if you wanted. So N, P, Q, X. Right? So N is the number of trials, P is the probability of success, Q is probability of failure, and X is how many successes you're interested in looking at. And then of course we can look at probability of getting X successes. So we need a problem. Let's do one of these examples. See how we can do this on Excel. What do you think? How about favorite nut?
Where are you?
55% of adults say cashews are their favorite kind of nut. Actually, a legume. Not even a nut. Anyway, they're pretty good. You randomly select 12 adults and ask each to name his or her favorite nut. Find the probability that the number who say cashews are their favorite nut is exactly 3, at least 4, at most 2. Okay, so what would N be? How many people were we asking? 12, right? So it's the number of times running the experiment. The experiment is asking the person what their favorite nut is.
What question were you on?
Yeah,
So I'm on
where are
page
you?
217, number 21.
Oh, okay.
So again, the experiment consists of randomly picking an adult and asking them, is your favorite nut a cashew or not? So we're doing that 12 times. What's the probability of success, where success will be defined as the person saying their favorite nut is a cashew? 55% would be 0.55. And Q would then be
0.45.
0.45. So you can type that in. You can also do a formula. 1 minus P. Have it calculated for you. So it's such a trivial calculation, it's kind of just showing off.
Yeah, a little bit.
0.45, right? Right, now X, we weren't concerned. X is going to be different for A, B, and C. But for, say, part A, it's pretty clear cut. X is 3, right? Part A, we want to know what's the probability that exactly 3 people would tell us that their favorite nut is the cashew. That means we'd have 3 successes. Right, the probability is then something that you could figure out with this complicated formula. But if you're using Excel, you might as well go ahead and use the built-in one, which I'm pretty sure do equals, and then it's B-I-N-O-M-I-D-I-S-T. Binom dist. Returns the individual term binomial distribution probability.
All right.
So B-I-N-O, I'll do capitals. B-I-N-O-M, binom, D-I-S-T, distribution. So to equals, binom dist, parentheses. Now, give me the numbers, trials, probability cumulative. Now, one thing you can is, you can type it in there if you know what's going on, but say you want to get kind of a more user-friendly GUI for this function, you can actually go to this thing. Wait, I thought you could. Sometimes you can go to these things and they can, yeah. See, I can kind of click on this. You can click on that function and it gives you a little interactive worksheet. At least I thought it did. Maybe this gives you the help. Anyway, this gives you more information on it. So, the first number we put in there is the number of successes. So this actually corresponds to X. So when we do this, do equals binom dist, and then you put parentheses, and then you would put in X, right? How many successes you want. The next thing is trials. That's the number of trials. That would be N. The next thing is probability S. That's the probability of success on each trial. That's actually P. And the last thing is cumulative. This is a logical value that determines the form of the function. So I wouldn't mess with this. I think we could just leave that blank. If it's true, it's cumulative distribution function. Oh, so this is if there's at most. So if you put in true, would be the probability that there is at most that number. Put in false, probability that there are that number. So maybe we need to put in false.
All right.
Because we want to know the probability there are 3.
Mm-hmm.
So we need to use false. So it looks like we have to use that. Let's try to mess with putting that in there or not putting it in there. So the number distributions, that is x. So we go x first, comma, and then n, comma, and then p. Notice you don't have to put in q because it knows if it has p, it knows that q has to be the other value. It's built in. What happens if we just close it off? Oh, you do need to add it. So cumulative, let's go ahead and put in
Wait a minute now. So tight.
false. So those are the values I put in there. And this is for exactly 3. But once we have this typed in, we can change the number to whatever we want. And we can get the probability that's exactly that many values. So you could create a table here, and from that a histogram pretty easily. So, probability that 3 of the 12 people would say catches their favorite nuts is 3% chance. Doesn't seem that high. Right? What do you expect? You expect more than half of them to say it, right? So you'd expect 6 or 7. It's not as likely that 3 would be. Notice I can change this number to whatever I want, and it'll update automatically. 1, 2, 3, 4. Notice if we go to like 6, right, and 7, we get much better probabilities. 7 and 6 giving us the best because, of course, 55% times 12 would give us somewhere between 6 and 7. So 6 and 7 are the best values. Anyway, this is probability of exactly x successes. Here x is 3. So that's what they want. 3. 2.77% chance. Now, what about this at least at most business? Well, you couldn't use this function and work through and add stuff up and kind of work from there. But we can also probably use that true-false thing we had previously. And so let's do, I think it was at least. So all these values are the same. Binomial dist, we go up and get x, go up and get n, go up and get p, and then we're going to go ahead and put in true here. Like that. So if it says true, it's the probability that there are at most that many successes. So that's giving you everything up to that value and including it. So for instance, right here, put in true, and we have 3. This would be the probability. We get at most 3. What numbers does that include? At most 3 successes. The probability that at most 3 people said that cashews their favorite nuts, that would include the probability that nobody said it, probability that 1 person said it, probability that 2 people said it, and the probability that 3 people said it. Right? Everything up to 3, 3 being the most. So you can see it's bigger than this because it includes that, but it also includes, right, 2, 1, and 0. These are all very small, so even all that gives you just 3.5%. So we could use this to answer part C, actually, right? It says part C, what's the probability that at most 2? You just change this to 2, and that is the answer for part C. The probability that at most 2 people think cashews their favorite nut is 0.00788. Now, there's no way with that true or false thing to get at least. So you got to fool around with that whole 1 minus thing, right? You know, altogether they give you 1. So this should be less than x. Well, 1 minus that. So I just did 1 minus that, of course. This just kind of splits it up and saying, right, at least, at most. Am I counting this one twice? Seems like I am. Probability that you get at least 4. So that's the probability of at most 4. That includes 4. 3, 2, 1, and 0. Probability of at least 4 would also have to include 4. So I don't know if it is that easy. You're going to say 1 minus this, but then you have to also subtract that. Oh, add that back. Sorry. Because this is actually including x, and you're taking that away, and you want to include it in this one. Both of these include x. This includes x and everything less than that. This includes x and everything bigger than that. So you can fool around with these things a little bit, or you could just find it for each value and add them all up. Sometimes the shortcuts are more complicated than a long way of doing it. Anyway, I'll put this spreadsheet up there so you can look at these. Try to figure it out. But that should be the answer to part B. 0.96. 96% chance that at least 4 of those 12 people would say that cashews are their favorite nut. Anybody in here? Cashews, favorite nut?
I don't know. Can't really say.
I wonder how people responded to that. They're pretty good.
Cashews.
I used to like pistachios more. Cashews are pretty good. Brazil nuts are pretty good.
Oh, what's my favorite nut?
Almonds?
Almonds.
Oh, almonds. Yeah, I don't know if I could choose. No? You don't like almonds?
They're my favorite nuts.
Do you have, was it almond butter? Like I said, peanut butter, but with almonds?
Oh, yeah.
That's really good stuff. Cashew butter, too. Cashew butter. All right.